Okay, let's look at another example. It's the best way to learn how to run these tests. And so we have a situation where a insurance company is trying to determine the life expectancy of their policy holders. And right now, in the past, it was 77 years. And so what they do, they randomly sample some of the recent paid policies to find the mean life expectancy of the current group. And so what we want to do is, here's the sample. There's 20, okay? 2, 4, 6, 8, 10, 12, 14, yep, 20. Now notice there is no sample date. The summary statistics not given to us. We know there's 20, degrees of freedom is 19, but I don't know what the mean and standard deviation are. So when you're given the data instead of the summary, you then have to do a put the data into StatCrunch. And sometimes this may happen when you're given the data, right, with data instead of summarized data. And then you have to do what we know how to do, summary statistics, columns. And I need the mean and standard deviation. This is sample, so I just need the mean and the standard deviation. So we'd calculate that, compute. There's our numbers, 78.6. and 78.6 and 4.477. Let's go with those numbers, 78.6 and 4.47. So 78.6 and 4.4, go back there, 4.477. Sorry for the writing, 4.477. So those are the numbers we're going to use to go ahead and calculate, right, our test statistic. And so we're trying to see, again, is this enough evidence to say that the mean age of the policyholders is greater than 77? This sample is, but it doesn't mean the population is. So you go through the steps, null and alternative, greater than 77, because you want to know if it's increased. One sample, again, since there is no alpha given to us, we'll use the 5% level. Again, that's per choice, technically, by the researcher or the one conducting the study. IRL, do we meet the requirements? 20 is less than all percent of policyholders. It's a random sample, randomly sampled. It's not greater than 30, but when we look at the distribution of these values, it's approximately normal, right? It has a normal shape, which is one of the conditions. And so we're going to utilize our technique, this one sample t-test. We're going to use the values here. So it's 78.6 minus the mean 77, and all of that over 4.477 over square root of 20. And I'm going to use a calculator to type this exactly as is instead of rounding, and I'll get one value. And so I get, when I calculate this out, 1.598. And then remember, what we need is a t-statistic. I need to find the probability that t is greater than or equal to 1.598, right? And so then we go back to the t calculator, 1.598. We're going to use stat calculators, t calculators. Probability, degrees of freedom is n minus 1. N was 20, so it's 19 again here. And the probability that it is more than 1.598. Compute that, and I get a p-value of 0.063. 0.063 is our p-value here. And then we use that, right, since the p-value is greater than alpha, right, which is 0.063 is greater than 0.05, we fail to reject the null hypothesis. So this would be this. Oops, failed to reject. Let me fix that. So I like to put a mark there that this is what we're accepting essentially and rejecting that. And since that, we can say there is insufficient evidence to conclude that the mean life expectancy of all policyholders is greater than 77 years. Now, remember, if I rejected the null hypothesis, if I did, we would then say there is sufficient evidence to conclude, right? Because we're always testing to see if our sample data is enough to reject. It's not in this case because the p-value is not less than alpha. If alpha was 0.10, right? If alpha, just to make a note of this here, right? Special note, right? If alpha equals 0.10, then we, let me make this separate here. We would have rejected, right? H. And it's, again, goes back to our ideas of which we'll talk about later, type 1, type 2 errors, this idea of making the correct decision, how it's our confidence level, right? We're 95% confident, 90% confident, right? And so if we used an alpha 0.10, we would have rejected the null hypothesis, right? And then we would have said there is sufficient evidence to conclude, but we would have had less confidence in our conclusion. And that's it.